This is a quick demonstration of the Analog Discovery 3's ability to display eye diagrams, which are used to look at the performance of clocks, digital clocks. So down here I have set up a sort of poor square wave. It's just a trapezoidal waveform at 1 megahertz, and I can run that and look at it on the scope up here. And if I want an eye diagram, I just click on the eye diagram menu item here, and it pops up the eye diagram. Now it's showing a trace here which is very faint because this is an extremely repeatable waveform, so it's not really easy to see it here. But suppose I want to add a little jitter. I can do a little bit of frequency modulation to create some jitter on the clock, and we will get horizontal lines here on the waveform. So let's try that. So if we add in a little FM, you can see that there's jitter in the crossover in this eye diagram, and you can see it jittering on the scope up above as well. However, the amplitude is very consistent because we're only doing frequency modulation, so there's not much amplitude variation here. So if I want to also add in some amplitude modulation, you can see that it does add some amplitude modulation, which you can see on the scope bouncing around a bit, and it's easily visible right away on an eye diagram. So that's really a very quick introduction. I'm not an expert at all on eye diagrams. This is the very first time I've ever played with them, but it's really cool that this device can show you not only eye diagrams of clock signals, but it can generate clock signals with varying amounts of jitter and amplitude noise that will allow you to learn more about how eye diagrams look when exposed to various kinds of signal. Very interesting. Just a couple of more quick notes. I've turned off the wave generator, and the eye diagram, of course, is not there. The scope trace is not there. But if I run it again, you can see how the eye diagram gets built up over time as it's overlaying consecutive scope traces, basically. So if we run this, you can see it's building up over time. And if we want to increase the amplitude modulation to get this vertical amplitude to be a little bigger, we go to 20%, and you can see right away that the vertical noise has increased significantly, and it's looking a lot more like an eye of an eye diagram. And if we want to increase the frequency modulations, say 0.3%, boom, we can see that it builds up over time to be a lot broader on the horizontal jitter. So that's a really quick introduction, but I think it's very cool that I get to play around with this and learn how to use it.